7.5 proportions and triangles. We're going to start it off with a theorem. Sachs-Glitter theorem. So it's saying if we know two lines are parallel, especially in a triangle, when you know two lines are parallel and they have that included angle the same, then we know that this proportion is true. So kind of let's label that so it's easier to see what we're actually talking about. So it's saying this little guy over this guy, so the smaller portion of the triangle over the side of the smaller triangle will be equal to the same across from it. So like, let's say if I was looking at this, a lot of times I will say, look at the picture. It's already set up for you in the sense that we could draw a line here equals and a line here. That's what this property is saying, this theorem. So if I look at this, this is the theorem that I'm setting up. 12 over x plus 1 is equal to 9 over x, because this over the smaller portion will be equal to this over this smaller portion. Now, to solve this, we want to get rid of that division. So I multiply this side by x and multiply this side by x plus 1. Remember, I have to distribute this 9. So 12x is equal to 9x plus 9. Move over my 9. I have 9x, or subtract 9x on both sides. I get 3x is equal to 9. Divide by 3, divide by 3, I get x is equal to 3. Now, I would go back to, okay, what is the question actually asking? This question is asking for the value of x, so that's my final answer. I want you to pause the video and I want you to try to do B by yourself right now. So we have a over a plus 4 will be equal to 12 over 18. I get rid of my division, moving it up top. So I have to distribute this 12. This becomes 48. I subtracted my 12 and then divide by 6. I get a is equal to 8. So another theorem that we have going on here. If we know that all of these are parallel, okay, now we have that AB over BC will be equal to WX over XY. So it's kind of like the same thing, except we just have another line that is parallel there. So here I'm looking for what is the value of X. Now we just went over this and it was when we had it like this. So it would be line equal line. However, so I have 62 over X, it would be equal to 56 over 70. Okay, that's using it this way. Now, what if I drew it like this, line equal line? Here I'd have x over 70 is equal to 62 over 56. Does it matter which way we have the fraction and the equals? Either way we solve these, either way that I set it up, I still get 62 times 70, which is 4,340, will be equal to 56 times x. So it doesn't matter if you have the fraction and then the equal and the fraction, or the fraction equal fraction here. So I would divide by 56, and I get x is equal to 77.5 feet, because it's asking for length. So another theorem. If we know we have an angle bisector, you have to make sure you have an angle bisector in a triangle. Then we know CD over DB will be equal to CA over AB. Otherwise, you could also do it like the fraction equal fraction. Remember that fraction equal fraction, because of that proportion, it doesn't matter the order in which you write it. So if I'm looking at this picture, because right here, these two are congruent, so I have my angle bisector, I could draw in my fraction here, my proportion right in that location. It'd be the same thing as if I turned this and you had this be the fraction, but we're not going to do that because it's easier if I do 10 over 12 is equal to 18 over x. Pause the video and solve that equation. You should have got x is 21.6. So this value is 21.6. So right now for B, I want you to pause the video and try to figure out what y is. Pause the video and figure out y. So I have y over 9.6 is equal to 24 over 16. If you ever want to make sure that you have this written right, either the line right here, the two numbers on the same line should either be across from each other or else they should be on the same fraction. So if I got rid of my division here and here to divide by 16, you should have got y is equal to 14.4. So now these are using those same properties, except now the algebra gets harder. The algebra gets harder here. So first I'm going to set up my equation. Put my fraction equal fraction. So I can have my 2x over x plus 4 is equal to 12 over x plus 1. And now this is where it starts getting harder. So I have to get rid of my division right here. I have 2x times x plus 1 is equal to 12 times x plus 4. I have to distribute that in. So this becomes 2x squared, because x times x is x squared, plus 2x is equal to 12x plus 48. And now, because we have this x squared, we have two possible answers. Now we must use the quadratic formula. So I'm going to subtract my 12x, subtract my 48. So I first set it equal to 0. 2x squared minus 10x minus 48 is equal to 0. Now I want you to try to pause the video and do the quadratic formula right here. So my a is 2, b is negative 10, c is negative 48. Plug it into my quadratic formula. This right here is a perfect square. The square root of 44 is 22. Now you must split it up. This becomes 32 divided by 4, which is 8. This becomes a negative 12 divided by 4, which is negative 3. However, now we're dealing with numbers in a real world problem. So we have to think, do these two numbers make sense in this? So if I were to plug in 8, would these all make sense in this? It would, because I get positive numbers because these are lengths of a triangle. If I plug in negative 3, does that make sense? Well, negative 3 plus 4 is 1, so that works. Negative 3 plus 1, that's negative 2. You can't have a negative two-side length. So my one and only answer here is 8. My one and only answer is 8. Right now, I want you to try to pause the video and try to do B by yourself. Here's my proportion. Get rid of my multiplication or my division. So I multiply that up, multiply that up. Here I have to subtract this 15. I set this equal to 0. My c here is 0. So a is 3, b is negative 12, c is 0. Plug into my quadratic formula. This becomes the square root of 144. Sorry, I didn't write that in. So the square root of 144 is 12. So 12 plus 12, that's 24, divided by 6 is 4. 12 subtract 12, this is subtract, is 0. So does this make sense in this problem? So I plug in 4. Yep, 4 makes sense. Do I plug in 0? Well, that doesn't make sense. You can't have a 0 side length here. So my one and only answer is x is equal to 4. We are going to do the last one in class together. There you go. Have a great, grand, wonderful day.